Okay, this is, in my opinion, this is a really big opportunity to kind of like really pad your grade, because you got 2 tests over not a lot of material here, right? I mean, this is not a huge unit. You get technology on a lot of this. Half of this test 5, is broken into test 4 and test 5. Test 5 is really mostly about just being able to use the technology. Okay, so what do we got going here? Linear regression examples. I want to look at those real quick. Does that seem really dim? Like dimmer than it's been? Oh, let's see here. I think they're. Yeah, I can do that. That's better. There we go. Okay, so linear regression examples. How many people, raise your hand if you need a little practice on linear regression? Anybody having struggling with that at all? Okay. Okay, that's not a good sign.
Oh yeah, I got a 75 on one of the and I didn't even try to redo it. It was too hard.
It's
wrong and you have to redo the entire problem.
okay. So I picked problems on the test that are going to not take you long to do, because you can cut and paste. Yeah.
You have to use R and R squared. Okay, I'm just curious, what does R mean and what does R squared mean?
Okay.
R squared is
Okay, let's answer that. What's R versus R squared? Because that's going to come up when we do regression. What do we call R? No. R is the correlation coefficient, right? We don't do a ton with that right now, but really what that tells us, if it's positive, it means that you're going to get a regression line with a positive slope. If it's negative, you get a regression line with a negative slope. Okay. R squared can never be negative. R squared is what we call the coefficient of determination. There's a question on the test where you have to know that. And when you go through the review, you'll see that. This is the one that we can convert into a percentage, right? So this is the one, like if R squared is equal to 0.85, let's just say, then that means 85% of the variation in the output variable is explained by variation in the input variable, right? So it's telling us kind of essentially how good a fit is this, like an 85% fit to the model, okay? And we'll look at a problem like that today. All right, so let's try one of these together. This is the stuff where you're going to be using Desmos graphing. Okay, so what do you do on this? We're supposed to draw a scatter diagram, determine the regression line, and then graph the linear regression line on the scatter diagram. So this is all stuff that's going to be completely done for you with technology. I'm just going to click on that little copy icon, copy to clipboard, and then you can't see that right now, but if I make this smaller, you can maybe. Let's try that again. There you go. And so it highlights everything, all the data. You have to hit Control. You got to actually copy it. So you hit Control C. And then in Desmos graphing, you're just going to paste all that stuff. Okay, look what it does. And then, so not only does it do that, if you click the plus, the zoom fit, it even zooms in on the data. This makes it really simple to pick which is the correct graph, because it's that graph, right? Here, let me just take a picture of that. So you got to pick which one of these is the right one. You can kind of see that's it right there, isn't it? Isn't that the one that matches? Like if I, there's that one. Isn't that what matches that?
Pretty darn close.
Right? I mean, of all the choices, that's going to be the obvious choice. So, I mean, really, you're just using the technology to create a scatter plot. And this just, you're verifying that you can make a scatter plot. So that's no big deal. Okay, part 2. Part 2, and then, okay, it asks you, this appears to be what kind of a relationship? Which one? Linear negative, right? And that was the one, okay? We want to write the regression line. Okay, well, create the regression line. I don't really need the graph here for this stuff. Okay, so I do y1 tilde, right? That tells me that's Desmos's way of building a regressional model. Y1 tilde m x1 plus b. Okay. No, you just got to know how to do it. You got to know how to use technology. So this gives you everything you need to know, right? Okay. It tells you the values of M and B. It's going to ask you to round those. You got to look very carefully. It's up to you to look to see how many decimal places you're rounding it to, right? You got to look at the little blue writing under the answer box, and it always tells you how they expect, like how the answer should be formatted. So there it is. In later questions, they're going to ask you about R squared. Well, there it is. There's R squared, right? It gives you all that information. Yes. R squared is the percentage. That's the coefficient of determination. R is the correlation coefficient. We're not, I mean, in future years, you'll do more with that, but not so much this year, okay? Well, the R squared is the one that's telling you the percentage fit, okay? Right, and that's the one that's always positive, so it makes sense, okay? All right, so then we would just take these numbers right here. Here, I'll do this, let's see. Okay, so then we would go into our regression model here, and there it is, right? We're just plugging in that value of M and that value of B into the regression model, rounding to 3 decimal places. So that means that, what's that telling us then? So the slope rounded to 3 decimal places is negative 0. What? 695. There it is. Okay, the y-intercept rounded to 3 decimal places is 6.531. Exactly. Okay. And then we want to choose the correct graph below of the regression line graphed over the top of the scatter plot. So all you'd have to do there in Desmos graphing is we want to graph, well, there it is, right there, right? That's it. Okay. And so we would just match that picture to the correct graph, which is going to be, you tell me, which one, A, B, C, or D? D. Yep. Okay. And that's it. Okay. Next one. Next one is all they're wanting here. Okay, this is same kind of stuff. They want the regression equation, but they want a prediction as well. Okay, no big deal. So we're going to do the same stuff. We're going to go up here. We're going to copy to clipboard. I'm going to Control C, copy it. I'm going to go into Desmos. I'm going to paste. There's my scatter plot, right? Okay, I can kind of, I can make that picture look however I want to. I can zoom out a little bit if I need to, but there it is. I'm going to go down and create the regression equation, same way, y1 tilde mx1 plus b. There it is, right? There's all my stuff. Okay, so that's all we need for the first part. But for the second part, they want something more. They want to know predict the well-being index, which is the output, right? That makes sense? Predict the output based on an input of 30. Okay? So do you remember how I would do that with technology? Into what? Okay, but I don't want to make it y because I want to be able to input values. F of x. Good. I want to write it as a function. So f of x equals mx plus b. And I don't have to type the values because it's going to keep all those decimal places, and probably it's even got more decimal places than that behind the scenes. Right? Desmos is calculating and keeping those values, storing those values. So it already knows what m and b are, so I can just write those in as mx plus b. Now all I have to do is go down to the next row and evaluate that function at 30, and there's my answer. Okay? So let's okay, so then what's that going to give me for my answer? So I'm going to round to 3 decimal places, so that's negative 0.083. And then my y-intercept is 69.095. Uh-oh, that's going to be a problem. Negative, okay. And then what's my predicted output? 66.600, yeah. Okay, make sense? Check answer, got it. Okay, give me thumbs. Okay, all right, next. What is this? R squared is what? Coefficient of determination, freebie. Okay. Okay, which one of these is going to be the R squared of 0.62? I got 0.62, 1, and 0.9. Which is the top one going to be? 0.62. So that's going to be A, right? Or that's going to be, yeah, 1. Okay. Second one, 1 is going to be which one? 3. Good, which means that one is 2. Easy. Okay. Okay, this is the one about interpreting the variation. So we would do the same kind of thing on this guy. I'm going to copy all the data. So Control C. Paste. Go down, make my regression equation. And now you guys tell me how to use that information. Oh, there it is. Hold it. Where is my? Yeah, but I kind of messed that up. Where's my? I don't think I copied. There we go. Do this again. Okay, there we go. So the R squared is as a percent is what? And they want to round to 1 decimal place. $91.0, right? Okay. Everybody get that? Questions? Okay, so now how about this? Interpret the coefficient of determination. What's that telling me? 91.0% of the variation in what is explained?
Let's just put height and see what happens.
It's explaining, it's saying that 91% of the variation in the output variable is explained by the relationship. So what's that going to be? Head circumference. There you go. Okay? Yep. Yep. Okay, I don't think we need to do any of those. We're good on all those. Okay, we did that. Okay, let's look at just a couple quick examples of these. I know these are so simple, but I just want to make sure everybody's okay with this. So on these, remember, what's your strategy when you're solving any kind of math stuff? First, you have to define the variables. So read through this real quick and tell me what's x. First number, what's y? Second number, okay? So now we've got to come up with two equations. Where's the first equation coming from? Okay, good. The first spot, and then what's that going to look like? X is, just looks like that, doesn't it? Right? For one number is X, is means equal, 4 more than the second is just Y plus 4. How about this one then?
Y equals 4x minus 6.
So 4 times the first, what's that? 4x equals 6y minus 12. There you go. Just like that, right? Okay, give me thumbs. Make sense? Okay, once I've got both of those, all I've got to do now is technology, right? I have technology on this test. So how would I easily solve that system?
Put it in a graph.
Graph them. I don't have to solve for y. I just enter the equations just like they are in Desmos graphing. Find the intersection, done. Okay, how about that one? So first of all, what are the variables? Read through it real quick. And look for the question. What's it? Number of tickets of each type, right? So we've got $25 tickets and $40 tickets. Okay? Where's the first equation coming from? There's some kind of implied information here. Like, what's an important word in this? Okay, good, because we have a sellout performance, so all the seats are being sold. There's 6,000 seats. There's our x plus y equals equation we always try to look for. It won't always be there, but usually it is in the systems equation, right? So this is the one that's just going to give us x plus y equals 6,000, right? Now, what's the other stuff?
25x plus 40y equals 181,000.
There you go, right? The total revenue, and that's going to come from the $25 ticket sales plus the $40 ticket sales is the total ticket sales. And again, all I'd have to do, what are my options here? I mean, I could either graph this, which is fine. That's a pretty big number. So the graph might be a little bit inconvenient. It's fine. I could also just throw that into a 2x3 matrix, right? Because it's already in standard form. Okay? All right, last thing, I'm going to let you work. How do we interpret this? This is from the first one, the first test, test 4. This is all that's given to you. You have to just interpret the answer. Okay, how come it's no solution? There you go. Good. You just look at the bottom row, and that's telling you that this one is no solution. Now, what if those were all zeros in the bottom? Infinitely many solutions. Yeah. Okay. Easy. Right. Okay. On the test, though, honestly, I think you'll see it on the review, but I don't even think I gave you one like this. I think I just kind of simplified it on the test, so you're either just choosing are there infinitely many or no solutions. You don't even have to specify the constraints. Okay. Okay. I mean, seriously, this is not bad, right? I mean, this should be pretty easy. Okay, get to work. Go. Brief. I just want to wrap up a few more things here, and then I'll let you guys get going on this. So when you're doing the matrix stuff, if you get answers that look like this is the answer. After you do RREF on your matrix, you set it up and you do RREF. What does that tell you? Okay, good. So this is like a normal single solution type of result. We know what that looks like. That's the look we get when we get the descending diagonal of ones. We get the upper triangle of zeros, lower triangle of zeros, and the solutions, right? So this is one that looks like that. Okay? What about if you solve the matrix in the matrix calculator and you get something like that? Infinite. Good. So that doesn't match the single solution look, right? It doesn't have a unique solution. There's no one diagonal of ones and zeros everywhere else. So then we always just go to the bottom row. And what equation does that correspond to? 0 equals 0, which is true. And so this is one where, remember on the test, I took out the part where you have to solve in terms of z. This is what the question is going to look like on the test. These are the three choices, right? So then all you have to do is infinite solutions. That's all you got to say is infinite solutions. You don't have to be more specific than that. Okay, make sense? The other stuff was kind of just I wanted you to see it on some homework, but I'm not going to test you over it. Okay? Give me thumbs. So we're all good with that so far? Okay. What happens if you get one like this? No solution, because the bottom row is telling us 0 equals 6, which is false. So we get no solutions. Okay, good. Okay, the only other thing I thought that maybe you guys would want to do that we didn't do on Friday was go through, and you can tell me about that. I mean, if you don't want to, that's fine, but I thought maybe it'd be worth, on the first test, where you don't have technology, solving a 3x3 linear system. Do we want to go through one of those? Or actually, I've got two of them here. We can go through both if you want to. So, okay, so what about one like this? If we're solving one of these algebraically, remember what our strategy is here is we want to figure out how we can look at two different combinations of equations and eliminate the same variable. So which variable would it be easiest to eliminate twice? X would. Absolutely. X would in this case. Y would be a terrible choice. Z would be okay. That wouldn't be horrible. But X would be the best because 2X I can easily cancel with 4X or 6X. Everybody see that? So like if we took these two equations right here, if I leave the top one alone and I multiply the bottom one by -2, look what we'd get then. The top row would just be 4x minus 2y plus 2z equals -20. If I multiply -2 through the middle row, I'm going to get -4x plus 14y minus 8z equals 38. Okay, and if I add those up, cancel the x's like we said we were going to, I get how many y's? 12. 12y minus 6z equals, what was that supposed to be, a 20 in the top one? Yeah. So that's given us, 18? Okay, so there's one. On the other side, we'd do the bottom two, right? I'd multiply this guy by -3 and just leave that one alone, right? So that's giving us, if I distribute -3 all the way through, I'm getting my -6x plus 21y minus 12z equals 57. Bottom one we leave alone. if I add those up, again, we cancel the x's. We get 36y minus 15z equals 63. Okay, now what?
Multiply the red one by 3.
Okay, right. So now we've got a system. Look, we got a system of two equations and two unknowns. Okay, and there's a couple things. Anybody see another thing you could do?
You could divide the blue one by 3.
Yeah. Okay, and we could divide the red one by something too if we wanted to, right? You don't have to do that, but you can. Just to simplify things, right? So I could make a system out of this where I could divide this whole thing by 6 in this case if I want to. I don't have to, but if I do, that's going to give me 2y minus z equals 3. Just get slightly smaller numbers, right? And this one over here, you guys said divide by 3. Is that right? Yeah. If I divide by 3, and I'll push that over into our system, I'm going to get 12y minus 5z equals 21. Okay, good. And again, I didn't have to do that. It makes things a little simpler, though. I get smaller numbers. And now, which variable would I probably want to get rid of? I mean, I could. I mean, they're both pretty simple. I could probably just do z here. Just multiply the top one through by -5. Bottom one, leave it alone. So I get -10y plus 5z equals -15. 12y minus 5z equals 21. And so as advertised, the z's cancel. Okay, good. Any questions so far? Let me pause here just to make sure everybody's on with me on this.
Can we go back to like one of the first steps?
Yeah.
Because
Mm-hmm.
I was a little bit lost. So you're just trying to get rid of the x's.
Right, and it's not always x. In this case, we want to get rid of x's because I could see that if I look at the bottom two equations, all I'd have to do is multiply the middle one by -3. And if I pick the top two, I just multiply the middle one by -2. So it's easy to eliminate x twice. Okay. So I'm going to do that. First, I'm going to take the top two and eliminate x by multiplying middle equation by -2. Then I take the bottom two, multiply the middle one by -3 to eliminate the x's. And the strategy here is, if I can eliminate the same variable twice, then I end up with two equations in two unknowns, which is a simple system, right? And then we're just going to solve that simple system, and it all just kind of goes downhill from there. It gets easy, right? So we solve the simple system, which we made our purple system. We're still doing that. And again, it makes it easier. I could have left the equation with 12s and -6s and 18. That's fine. And I could have left this one the way it was, and then I would have just maybe multiplied this one by -3 to get a -36y. Anybody see that? I did not have to divide to make those smaller. I did, but I did not have to. Okay. We got this system. We decided to get rid of the z's this time, so I distributed a -5. The z's drop away. So I get positive 2y equals 6. So what's y? 3. Okay, so we know y is 3. Now it just starts to collapse and get easy. So if y is 3, where do I go to find z? Purple one, and probably the top one looks pretty simple. So we'll just plug that y value in right there. No, just take your pick, just one of them. Yep, whichever one seems easier, right? Because remember, and the reason for that is because if we're solving a system, then it has to be the same solution is going to work for all the equations in the system. So just pick the easiest one. So that's going to give us 2 times 3 minus z equals 3. Okay. That gives us 6 minus z equals 3. So you could solve this any way you want to, but like let's say I push the z over here and subtract 3. Aren't I just going to get z equals 3? And you could also just ask yourself, 6 minus what is 3? Well, 3, right? So we got 2 of them. Now what? Yeah, plug them both into any of the original ones. How about the top one? That looks pretty simple, right? So if we plug those values in to the top one, we're going to get, what's that going to give us? We know x is, we don't know x. We're solving for x. So 4x minus 2 times 3 plus 2 times 3 equals negative 20. What's that give us? 4x minus 6 plus 6. So just 4x equals negative 20. So what's x? And that's our answer, right? Okay, makes sense? Okay, so then you could get one like that, or you could get one that has some things missing. That's okay. This one looks a little bit confusing at first, but it's actually to your advantage to get one like this because there's less to do, right? What could we do? Yeah, we could, right? If we cross out, yeah, so if we took the top and the bottom, we could cancel out y, couldn't we? So then we'd have to pick another pair of equations and also cancel out y, so we could pick maybe the bottom two, right? So what happens there if we, again, like if we just push these guys, push that one and this one together, okay, add those up, and we get a bunch of stuff canceling. We get the answer 6x minus 3z equals 0. There's one equation. Now we canceled out the y's, right? So we have to cancel the same variable twice. That's the rule though when we're doing this. That's our strategy. So again, we could pick the bottom two. We could just multiply this one by 3. Leave that one alone. If I multiply by 3, I get positive 3y plus 2z equals negative 11. Oh, it is. You're right. Forgot to multiply, didn't I? Okay, good. So if I multiply by 3, that's going to give me a 6z and a negative 33. Add those up, and the y's cancel, and I get the other equation, 2x plus 6z equals, what is that, negative 28? And now I've got two equations I can push together and make a simpler system. Okay. That's supposed to be an 8. And I'd probably, multiply the top one by 2? So I can cross out the z's. Make sense? Okay. I mean, so you guys are saying you could have made those simpler. Malone. If I want to cross the z's out, I could multiply by 2, leave that one alone. So that's going to give me 12x minus 6z equals 0. 2x plus 6z equals 28. Add those up. The z's cancel. I get 14x equals 28. So what's x? Did I mess it up? Oh, negative should have been, yep. So x is what? Negative, what was it again? 2, negative 2, okay. I plug that back into either of them. How about the bottom one? Actually, top one's got a 0. Let's do that. So we plug that in right there. 6 times negative 2 minus 3z equals 0. So negative 12 equals 3z if I push that over to the other side. So z equals negative 4. And I know x and z, I got to find y. Why not pick that one, right? Easy one. So if we pick this one.
You don't have to plug it into ones that are missing the variables, they have all the variables.
No, no, because again, I get to choose, right? If it's a solution, it must work in every equation. So always just pick the easiest one. So this guy right here would give me y plus 2 times z. What was z again? Negative 4, okay. 2 times negative 4 equals negative 11. So that's going to give us y minus 8 equals negative 11. So y equals negative 3. Everybody agree? And there we go. Okay, there's our solution. X is negative 2, y is negative 3, z is negative 4. Good? Okay. How many people want to how many people would rather just start tomorrow? Anybody? Okay, I mean, we're getting a late start, so that's fine. If you guys would rather, we'll just start tomorrow. I'll give you the rest of the period to kind of prep, and then we'll just go tomorrow. Yep. Question? Or yours ready? You're voting. Yeah. It is. It's 2 different tests, right?
One tomorrow, one Wednesday, or is it?
I mean, do your best to get through them, but it might bleed over into the next day. They're not super long. I mean, I think you honestly could do them both in one day, but if you don't, we'll take a little bit of time on Wednesday and finish them up. So it's the first test, just to remind you, the first test is the non-technology. That's why they're different tests, because the first one has no technology other than Desmos Scientific. The second one has all the technology. So matrix calculator, graphing calculator, all that stuff. Okay. Did I show you guys? I think I did. Did I show you guys this? Pretty sure I showed you. No, not that. Did I show you? Yeah, I did. I showed you how to do that. Okay, so maybe let's take a quick look at that.
Take a screenshot and put it in the notes. That would be great. Because we just talked about it last time. It wasn't like recorded.
Okay. Yeah. Okay.
No, not that one. Where like he plugs in each of the values for like this equals x equals y and just put it in the equation. I don't know.
That one, right?
Just the yeah.
Okay, so yeah, the way you can, this is just for checking solutions, right? But this is a really easy way to do it when you're checking solutions with when you have lots of variables. So what you're able to do, I didn't know this until very recently. If I want to like evaluate all 3 of these equations, what I can do in Desmos Scientific is I can just plug in the values of the variables. If I type in x equals negative 9 and I hit enter, it just shows me equals negative 9 on the right side of the screen. But the important thing is it stores that value as x. So I do that for each of the 3 variables, right? I'm trying to check to see if this ordered triple is a solution. So I go here. Want me just like, how about if I just go through it step by step? Would that be easier? Okay. So let's do this. If you want to pull up Desmos Scientific and do this with me, that's fine. Okay, so in Desmos Scientific, I would just type x equals negative 9, enter. Now it's in. I type y equals 8, enter. Z equals 3, enter. And now if I type that expression on the left side, if I do negative 5x plus 5y minus 3z, it calculates what that value would be with the values of x, y, and z that I already entered. Okay, it tells me 76. So that one would check. So I just go down and do the same thing for the next one. 2x plus 4y plus 3z, and it tells me 23. Okay, so that one checks out. So I go down to the next row and try it with the last one. 13x minus 4y plus 6z, and it tells me negative 131, not negative 15. So that's telling me that this is not a solution, right? Everybody see that? Okay. It checked out on the first two. Check, check, no. And for it to be a solution, it has to satisfy every equation in the system, and it didn't do that. Okay, good? All right, I'll let you guys work. And bring questions up if you have them.
So can we check our answers like on the test that
Wait, can we just,
for the
this
first
is on
test?
the scientific.
That's on site.
Yeah, so on the first test, you have Desmos Scientific always. So you have this on the first one, yeah.